So how do we create a NumPy array? Well, after we've imported NumPy as NP, we will henceforth refer to NumPy as NP. And so if we wanted to create a one-dimensional array, here's an example here. I just say np.array. Remember, we're using dot notation to say from the NumPy library, give me the concept here of an array. So it's giving you an array object. So you're creating an array object basically here. And in this case, it's a one-dimensional array. It's just a simple list. Here I might create a two-dimensional array, which is a list of lists. Here is a list of lists of lists, a three-dimensional array. Before you start panicking though, this isn't how you tend to create NumPy arrays, by manually typing in all the numbers. So if you're suddenly thinking, is this what I've got to do if I've got 200 dimensions in my machine learning array? No, that's not what you do. Don't panic. This is just to get you, give you a sense about how these things, the kind of syntax for working with them, and the kind of examples that you'll use in the training as you're learning NumPy, just very simple arrays to get your head around the concept of a NumPy array, because all of that will then scale up to these huge arrays in exactly the same way. You'll perform the same operations, you'll use the same syntax, it's just they're operating now in 100 dimensions instead of 2. So yeah, in reality, you would use various things that would automatically read stuff into those arrays. And there's really neat shortcuts that allow you to do that. So before we go any further, I need to talk about the homogeneity of NumPy arrays. NumPy arrays are homogeneous, and basically what that means is you can only store the same type of data, so whether that's integers or floats or whatever it may be, across the array. And NumPy arrays are only for numerical data as well, hence the num bit in NumPy. But it has to be consistent, so you either have to have an array of floating point numbers or an array of integers. You can't have a mix of the two. And also, the dimensions of a NumPy array have to be the same length consistently across the array, but can differ across dimensions. Now, that probably doesn't make sense to you, but let me put that into a real-world example. As an example, we could have an array which represents 3 departments. Each of those departments has 4 groups in each, and each group has 10 people. So they're all different values, but what we can't have is more or fewer than 10 people in each group, or more or fewer than 4 groups in each department. You can't have a department that has 3 groups and a department that has 5 groups. That's why I said the example I gave of think about a multidimensional array as being individuals in a group, in a department, in an organisation is handy for trying to get our heads around a multidimensional array. But that's not how you tend to store that particular kind of information, because you'll likely have, departments that don't exactly have 10 people in each group and have exactly the same number of groups, etc. So I'm giving this to you as a way to make this make your head hurt a little bit less, rather than this is how I would represent this kind of data using NumPy. So that's what we mean by the dimensions have to be the same length consistently. Now, that does mean that even if you are using NumPy for something where it is a bit more appropriate to use it, we will sometimes have 0 or missing data for some values, because everything has to be the same length. And we deal with that differently depending on what we want to represent. So sometimes we just put in 0 values. Sometimes we take average values. There's various different ways of imputing missing data, and it entirely depends on what you're doing. But for now, just be aware that NumPy requires there to be consistent lengths across in each dimension. So just to hammer home this point, this piece of code here, where we've created a NumPy array, this piece of code is not, the code is valid. It is not valid for creating a 2-dimensional NumPy array, however. So it will work, but that will not create a 2-dimensional NumPy array, as you might think, because here we've got, imagine this is our, we've got individuals in each of 2 groups. Here we've got one group that has more individuals than the other. That's not allowed in NumPy, okay? So you can input that and it will not throw up an error. What it will do instead is it will create a 1-dimensional array that has 2 elements, and those 2 elements will be references to two different lists. That's not what you want to do most of the time for NumPy, but you won't get the benefit of NumPy doing that. So just be aware of that little wrinkle.